Hi, my name is Georgie Fitch, and I am taking IB Sports Exercise. I worked on the claim and the Can't Get Enough Oxygen slides, and I am interested in the underwater mask because if this product could eventually work, it would benefit a lot of people.
Hi, I'm Jason. I was really interested in this project because I wanted to know how the makers of the Triton raised over $900,000 marketing their false technology. My contribution to this project are video editing, organization, script writing, and research.
Triton Underwater Breather, which its makers claim can allow a user to breathe underwater for up to 45 minutes. The creator behind Triton says that it will revolutionize shallow scuba diving, allowing anyone to breathe underwater up to 15 feet for the relatively cheap price of $300. Here's how the technology supposedly works. From the water, air is extracted through a filter which has holes smaller than H2O molecules, allowing air to pass through while keeping water out. From there, a microcompressor and a battery stores the oxygen with no pump required, allowing the user to breathe comfortably underwater. This campaign raises over $900,000 in a few weeks on Indiegogo.
Now let's get to disproving it. First, there simply isn't enough water passing through the Triton to sustain a human's breathing. At rest, an average person breathes around 7.5 liters of air per minute, which is a mixture of nitrogen, oxygen, and trace amounts of other gases. Scuba divers normally breathe around 14 liters of air per minute, as shown by this poll on a scuba diver forum. According to Henry's law and the solubility ratio, the amount of air in water is affected by two main factors: temperature and pressure. The colder and deeper, and thus more pressurized water is, the more air that can be dissolved in the water. Using an online calculator, in 15 feet of water, which is the highest pressure the Triton can operate under, there is approximately 21 pounds of pressure per square inch. Also, assuming that the water is very cold, which is an optimal condition for the Triton, the maximum possible solubility of air in water is only 0.0613, which means that in every liter of water there is 0.0613 liters of air. According to our estimates from before, being generous, a scuba diving human would probably use around 10 liters of air per minute. This means that the Triton would have to extract 10 liters of air from the water per minute to get enough air for a human to breathe. We then get the equation 10 liters of air over x liters of water equals 0.0613 liters of air per 1 liter of water. Solving for x, we get 10 divided by 0.0613, which is around 163 liters of water for 10 liters of air. For reference, a heavy-duty or strongest pressure washer only have about a flow rate of 4 gallons per minute. This is around 15 liters per minute. In order to extract enough air from water, there has to be an equivalent of around 11 heavy-duty pressure washers of water flowing through the Triton, and since there isn't even one pump pushing water through the Triton, this is simply impossible. Remember in the beginning when I said that the Triton filters air from water? Well, it's uncertain whether they're only filtering out the oxygen from the water or just the air, due to several conflicting sources reporting different things. If they're only extracting the oxygen, they would have to invent a small, compact method of separating the nitrogen and the oxygen in the water. This is conventionally done by two methods: cryogenically or non-cryogenically, and both require a much larger size than the Triton. Not to mention that the blueprint of the Triton never mentioned any device like this either, so it's safe to say the Triton probably does not have one of these. Deep Sea News also does a good job explaining why, even if the Triton only extracted oxygen, it wouldn't work as intended anyways. When we breathe, our lungs usually only absorb around 1/4 of the oxygen that they take in, which our calculations are premised on, as scuba gear usually releases the not absorbed oxygen in the form of bubbles, with other gases such as nitrogen. We've established that there's no way the Triton can extract enough oxygen from the water when the leftover oxygen is released. However, even if they recycled the leftover oxygen, there would still be a big problem: separating the CO2 our body releases from the oxygen. This carbon dioxide would build up, and after a few breaths, the user would experience extreme carbon dioxide toxicity, with symptoms such as unconsciousness. There's no way that the Triton could separate the CO2 and the O2 gas mixture. If they had that technology, global warming could be solved. And while some methods of doing this are being developed, there's not a chance that it's already miniaturized into the size of the Triton. Even if the CO2 and oxygen are separated using some sort of advanced filter, the Triton still wouldn't work. There would still need to be around 60 liters of water flowing through the Triton, which is still a ton of water without a pump. Also, keep in mind that all these calculations are assuming that the Triton had a 100% efficiency at separating oxygen and water, which is pretty much impossible, which all in all brings the Triton's chance of actually working to pretty much zero. In conclusion, the Triton can't filter enough water to get all the air needed for a human to breathe. Even if the oxygen that is released is recycled, there wouldn't be enough oxygen and the small CO2 filters don't exist very well yet. If the Triton only filters oxygen out of water, there still isn't enough water, and there's no mechanism for filtration of nitrogen and oxygen. Also, the Triton efficiency can't be this high, which means that these are the best possible conditions for the Triton and it still doesn't work. So the technology is pretty much impossible.